And the order is significant, especially when we get to the part with the reflections, because if the reflections happen before or after shifts, makes a difference on how the graph will look. All right, so I'm going to show you how we go through this in the series of steps that they need to be taken in. Okay, so when we talk about transformations, the first thing that we want to do is identify where those transformations where we can look at to identify the transformations, right? So I'm going to go through this in like a color-coded kind of in a fashion, right? So the first type of transformation that you want to identify and describe is anything that's happening horizontally, right? So if I'm looking for a horizontal shift, I'm going to look inside of my absolute value, and I'm going to highlight not only the number, but the sign, right? Why is the sign important? Because we've seen in our simulations that if you add a value, it shifts to the left, and if you subtract a value, it shifts to the right. Right, so that sign is critical because it tells us the direction in which we should go, or at least opposite of the sign, right? So the first type of transformation that you want to describe is going to be horizontal shifts, right? And you want to use that language, right? You don't want to say slide, you don't want to say move. You want to talk about horizontal shift because that's a very technical term that indicates you are moving the entire absolute value function as one solid piece, either to the left or to the right. Okay, and then you indicate how many spaces, right? So we're going to say horizontal shift. What can you tell me? Which direction? Horizontal shift 5 units left or 5 units right? And how do we know? Yeah, we want to go 5 units left. And how do we know that it's left? What is unique about H? It's opposite of the value. Great, right? So that's a good way to describe it. So you would go opposite direction of whatever sign you see. So if you see positive, you would go in the opposite of a positive direction, then you go negative, so you go left. All right, so we start with horizontal shifting, okay? Number 2, I'm going to highlight in a different color now, my A value. Now notice how I've highlighted only the A value, not the sign. Okay, why do you think that that's important? Why do you think I'm only highlighting the A value right now instead of the negative in front as well? Yes, right? So a combination of those things. So right now that we're talking about transformations, we're not really using the slope. Slope is our shortcut to graphing, but when we're talking about transformations, A does something. The negative does something else, right? Negatives are used when we do reflections. But right now I'm focusing only on what is the 2/3 doing, right? Because when I get to the negative, that's going to be something else. That's an entirely different type of transformation. So I don't want to clump them together. I want to treat them as separate pieces. Okay, so I'm first going to focus on just the 2/3. Okay, now what do you notice about 2/3? Okay, is 2/3 a number that is going to create a compression, or is 2/3 a number that's going to create a stretch? Okay, so it's less than 1, and because it's less than 1, it is a compression. Good, right? So we are going to say vertical compression, right? Which means we are essentially making the absolute value function more wide, right? It's a vertical compression, and now here's the terms that we want to use. Okay, it's not vertical compression by 2/3, or you want to say vertical compression by a factor of 2/3. Okay, and then that indicates that you're multiplying your value by 2/3, therefore creating the compression. Right, so it's a vertical compression by a factor of 2/3. You want to write it in that exact same format. All right, now sometimes you'll have vertical stretch, but you'll still use by a factor of, and you'll have some number there. Okay, so in this case, it's a compression because 2/3 was less than 1. Right? If it would have been greater than 1, then we know it's a stretch. right? And we saw that in previous simulations. Okay, after we've done shifting and compression, or it could be stretching, right? So after those two, the next one is going to be the reflections. Okay, so now the third type of transformation you want to describe is any reflections. And we've kind of mentioned this already, right? So we have a negative out in front of the A value. The negative is in front of the absolute value. So we have a reflection, we know that, but there's two possibilities. It could reflect over the x-axis, which causes the V to point downwards, or it could be a reflection across the y-axis, which causes the V to get mirrored onto the other side. Right? Which type of reflection is happening in this situation? Yeah, we have a reflection that's across the x-axis, okay? So the fact that the negative is out front just means that the direction changes. Your V shape, instead of opening up, it opens down. All right, so we can say then with confidence that it is a reflection across the x-axis. Okay, and then finally, plus 12, right? That's the only other part of the function that we haven't quite addressed yet. So what does that tell you? That the vertical shifting is the very last thing that we do in this order of transformations, right? So I mentioned that the order matters. It must maintain this order. So when you're describing them, you tell me about the horizontal shifts first, then any compression or stretching, then the reflections, okay, and then the vertical shifting, okay? So in this case, I have plus 12. So I'm going to begin my description with, it's a vertical shift. And how do you think we should end this? Twelve units up. Yes, sir. Thank you. All right, it's 12 units up. This is our K value, right? So that also indicates we keep, right? We keep that sign. We keep the positive 12, so that's 12 units up. Okay, now the question is like, why do we put the vertical last? A lot of times it has to do that if you were to do a vertical shift up and then you reflect, you end up on the other side of the x-axis entirely, right? You just imagine where this vertex is at the moment, right? This vertex right now should be at -5, 12, right? So -5 along the x-axis and then up 12. Imagine if you would have shifted it up 12 and then reflected over the x-axis. You would have ended up at -12, right? So the reflection needs to take place before the shift, because otherwise then you're going to have a vertex that is not where it should be, okay? So in order to maintain your vertex in the way that we've learned it, where it's an opposite keep, the reason we can say that is because the reflections happen before any vertical shifts take place, right? Just imagine, Fiki, you shift the vertex up 12 units, right? 5 to the left, up 12. Now reflect it over the x-axis. Where does your V end up? It starts way down at the bottom at -12, right? And that's not your vertex at all. So that's typically why we need to we need to do the shifting at the end after you've done the reflections. Okay, so I hope that kind of makes sense. Any questions so far? Kind of fun, right? Like the description part. We kind of know where to find things and we just talk about them, right? So it's kind of nice. Not only that, but it helps kind of create a mental picture step by step of where this graph is going. 5 left, compression, reflection, up 12, right? And now you know, okay, I kind of can see where that graph is at, right? So it's kind of nice. All right, let's move on. Let's take a look at the next one. All right, now you see all this wording in front of it, right? It says describe the transformation that takes place on the parent graph to obtain the graph of g of x. Basically what it says is, what do you need to do to f of x to get the g of x, right? How do you get from the parent graph to the new one? That's literally all it means. Okay, so it's a lot of words just to say that, all right? But it is kind of a technical, the question seems technical, but we're asking you just to tell me what happened from f of x to get to g of x, okay? And it's similar to the type of way that they phrase things on the SBAC as well. The questions are formulated on the SBAC in a way where the question is it's hard to understand sometimes, okay? So describe the transformation that takes place on this function to get to the next one, all right? That's literally all it means, all right? So this time, you guys help me, walk me through step by step, okay? What is the first type of transformation that I want to identify, and where do I find it? Horizontal shift, right? And what would be the number or the sign that indicates the type of horizontal shift that I will have? Yeah, the -3, right? So that's nice and easy. It's easy to find right inside the absolute value. Okay, so since it is a -3, I can say that this is a horizontal shift 3 units to the, which way? To the right. That's correct. Okay, it's the opposite of -3, right? So instead of going left, you go right. Very nice. Okay, that's the first transformation. Let's think about what the second one would be, right? What is the indicator for the second type of transformation? Yeah, I want to focus on 2. Now the question is 2 larger than 1 or smaller than 1? Yeah, so right now we're focusing, right, is it going to be a stretch or a compression? So because 2 is larger than 1, you're multiplying things by 2, they're getting bigger faster, right? So this is a stretch. Okay, so notice how, once again, I only highlighted the a value, not the negative, because the negative represents something else. So we're going to say here that this is a vertical stretch. And what is that vocabulary? What's that phrase that is key? Vertical stretch by what? By a factor of, right? Exactly, right? So that indicates that you are multiplying each one of your x value, or each one of those values by 2, which is what allows your function to grow much faster. So vertical stretch by a factor of 2. Right, so you see it's almost identical to the phrasing on the previous one, except stretch instead of compress, and then the number changes, right? So whatever you're multiplying by, that's what changes. Okay, what is then the next type of transformation we should expect, and where do we look for it? Yeah, we have a reflection, right? And the indicator for a reflection is you look for those negative signs, right? In this case, we have a negative in front of the a value outside of the absolute value. Therefore, we're looking for a reflection that takes place over the x-axis, correct? Good. So it's a reflection across the x-axis. Okay, now sometimes you won't have any reflections, and it's okay not to describe that, right? Like you don't have to tell me no reflections. I mean, it's not wrong, but if you don't have a negative out front, and then we'll take a look at the other type of reflection, which would be a negative inside the absolute value. If there aren't any, then don't describe them, right? You only describe the transformations that do take place. You don't have to describe the transformations that don't take place. Does that make sense? All right, and then finally, we want to take a look at that last value, right? And then this one will indicate what kind of transformation. Yeah, here we look at a vertical shift up 4 units, or vertical shift 4 units up, right? Sometimes I kind of mix those around, but same idea. Okay. Not too bad, right? Kind of fun. At least I think so. Says the math teacher, right? All right. Any questions yet? Any questions to this point? All right. I think we're good so far. All right. Let's take a look at the last type of transformation one. And this one is only different in one area. All right. So similar kind of approach. All right. So we still follow what we know. Okay. In this case, the first type of transformation is indicated by what on the function? Yeah, I want to look at that +5, right? So the +5 tells me where that first transformation takes place. Okay, so I'm going to say, all right, number one, we have a horizontal shift. Five units. Which direction? Yeah, we go left, right? 5 units to the left because it is a +5. We're going in the opposite direction of that. Okay, horizontal shift 5 units left. Okay, and then going back to your question earlier was kind of asking like, why does vertical shifting go last? There's also a reason why horizontal shifting goes first, and then it's followed by the reflections. Okay, we're gonna see that in this case, or why in this case, when you have reflections that go across the y-axis, why the vertex is no longer opposite keep and instead it's keep keep. Okay, we'll talk about that. We'll look at Desmos as well. All right. But for now, we'll just kind of keep going in our regular order. What would be the next indicator for the type of transformation I need to make? The A value, correct, right? The A value in this case is a 3. All right. So then what does that tell us? Yeah, we have a vertical stretch, right? So vertical stretch. Correct. And it's a stretch because it's greater than 1, right? You guys are right. All right. So vertical stretch by a factor of 3, right? Not bad. Let me clean this up. It's kind of messy. By a factor of 3, right? So we're expecting this to be pretty narrow, right? We're multiplying our values by 3, so we've shrunken the space in between the lines, right? They've gotten more narrow, closer to each other. All right. And then now number 3, right? We're still looking for a certain type of transformation, but where do we find it this time? Yeah, this time it's right next to our variable and it's inside the absolute value. So although this is not as common as what we've seen, it's still a transformation, it's a reflection, but across which axis this time? Yeah, you're right, right? So reflection across the y-axis, okay? Remember that this is a type of transformation that will essentially mirror across the y-axis, right? So if it's already been shifted, what it'll do is it'll kind of reflect and mirror, and then it'll end up being that many spaces away from the y-axis on the other side, okay? And then finally, what is my last indicator? Almost, it's a -8, right? So I would want to shift in which direction? Yeah, we want down, right? So vertical shift 8 units down. Okay. All right. Now, so like this should paint a picture, right? This essentially will tell you where your graph should end up, right? And I know that's kind of difficult to do because I'm not sure like what you guys see, if you see the mirrored version or the or the real version, but I'm gonna try to do it with my hands. And I don't even know if you guys can see me, but if this is my y-axis and my function is here and it's a shift 5 units left, I'm going to my left. So I'm going 5 units this way, right? Then I have a stretch, which just causes the V to get more narrow. And then I have a reflection across this y-axis right here. So then what happens? It reflects my V and it lands on this side now. And then I would just shift 8 units down. Right? So you see the horizontal shift moved me this way first, and then the reflection eventually brought me back to the opposite side. Okay, so watch how this transformation, how this function looks like on Desmos. We're going to follow this. Okay, I want to show you, and then we can kind of discuss it.